Okay, good evening. Now, the other day I could not complete my lecture because I was not feeling well. I think the previous to that last class, somebody has asked me a question about the accuracy and bandwidth, etc. There is a confusion in that question. You see, the number of bits determine the accuracy. Suppose a 3-bit number, 0 to 7. 000, 001, now there will be, this will have a switch which will be on or off to say that this level is 0 or 1. But when this goes to the next level, there will be 2 switches because it's a 0 0 or 0 1. This will be open. If this is open, this is 0 and this can also be 0. This can still be 0 and this can be 1. That is like this. Or this is closed, this is 1, this can be 0, this can be 0 and 1 and 1. Now this level will have 2 more. So this is how we form the switches. So the level concern of the level, somebody was confusing the bandwidth. There is nothing to do with bandwidth. We are not even talking about frequency. So levels are determined by the number of switches, but how do you determine the number required depends on what you are trying to measure. Suppose you are trying to measure 1 volt, and what is the accuracy you want? You want only half a volt accuracy, 1/4 of a volt accuracy. 1/4 of a volt accuracy can be done with 2 bits, 0 0 0 1 1 0 1 1. If you want 1/8 of an accuracy, volt accuracy, then you have 3. Like that you go on, but you should know whether it is really required for that. Supposing I can have, somebody was asking about 10 power 12 or something, 10 power 10, I mean 2 power 10. 2 power 10 is 1024 levels. 1024 levels, if you want to divide 1 volt into that, each level will be very small. And what parameters are going to measure with that? If it is going to be very critical, then you need that many levels. If you are going to measure the crude value, that many levels are not required. So that is determining the accuracy, not the. So this number of switches, any number of levels can be put, each level can have 0 volts and 5 volts. That is all I wanted to say that day. Okay. So it has nothing to do with bandwidth. The levels can be determined. How accurate do you want it? Do you want only 1 bit? That means only 2 levels are possible in the measurement. Do you want 2 bits? Only 2 levels are possible. 2 bits, 4 levels are possible. 3 levels, 8 bits are possible. 4 bits, 16 levels are possible, like that. So whether we really want the quantity of measuring to have 16 divisions, 32 divisions, 64 divisions, etc. will be determined. If it is, you should not have more than what you require. At the same time, you should not have less than what you require. Okay, but then the quantity you are going to measure, you should have the accuracy of reading. Suppose it is a voltmeter. The voltmeter accuracy determines this. You cannot have too much accuracy when you have a crude measuring instrument. Okay, that's enough. We also talked about complement numbers. I told you what is 1's complement, 2's complement. So any number can be represented in different forms. That is, the first is the number without unsigned numbers. That is, if you have 8 bits, you have 0 to 255, 256 levels, 256 counts if you want. I can use a counter. Suppose I want to measure, count the number of people coming into a hall. I need to know how many people are expected, what is the capacity of this hall. That determines the number of bits. I will have a negative value there. So there is nothing like a negative number, positive number. I am going to measure the number of people, count the number of people. So that is unsigned numbers. So all the 8 bits I can use, 0 to 255. Or if there are only 100 capacity, I need maximum 127 because there is no 100 is not a 2's power. So 0 to 127, which is 7 bits. Then I will have a 7-bit counter. Next is sign magnitude. Representation. So out of the number of bits, suppose again I have 8 bits. One bit goes for sign and 7 bits goes for magnitude. So if it is 0, it is a positive number, if it is 1, it is a negative number. So I can have 0 to 127. It can be 0 or 1. So that is minus 127 to plus 127. Minus 127 to plus 127, there are only 254 levels, whereas I can have 255 levels, but that is what you do for a sign magnitude. Then there is this one's complement. One's complement numbers, you have you represent the number and invert it. If it is a positive number, the sign bit is 0. Negative number, you invert all the bits. That is the negative number. For example, we will take an example of 4 bits to make it easy. I can have 0 as 0, 0, 0, 0, 4 bits, plus 1, 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, we know all those numbers. So for example, 4 will be 0, 1, 0, 0, 7 will be 0, 1, 1, 1. Since we have reserved this number as a sign, I can only have numbers from 0 to 7, positive 0 to 7, plus 0 to, so moment I want negative numbers, I invert each bit. So this becomes 1, 1, 1, 1, 1, 1, 1, 0, 1, 1, this will be 1, 1. So this will become 1, 1, 1, 0, 0, 1. Each bit is inverted. 7 will be 0, 0, 1, 0, 0, 0. Now, 0 has 2 representations. There is nothing like plus 0 minus 0. So this is 0, 0, 0, 0 is also 0. 1 1 1 1 is also 0 in 1's complement. Again, when there are 4 bits, I should be able to represent 15 numbers 0 to 15, whereas I can only do 0 to 14 because this is 0 to 7, this is 0 to 7, this is 0 to minus 7, so 0 is saved, 7 and minus 7, there is only 14 representation in addition to 0, 15, not 16 as we can do it in 4 bits. So all we have to do is to invert each bit. That is 1's complement. Then there is a 2's complement. The 1's complement is simply, you see this like this. So I can also have a decimal number. The decimal number, I can have 9's complement. For example, I will make 2 digits, simple, 2-digit numbers. Let us say I have 27, decimal number. You put the label here, indicate it is decimal number. So 9's complement of this, I subtract it by 9. So it becomes 2, 7. So 7 2 is 9's complement of 27. So there is no need it has to be positive or negative. Here also, because I reserved 1 as a negative bit, sign bit, I am getting this 1 as this 0 as a positive and 1 as a negative. I can simply do this. Suppose you have a 4-bit number. Um, 1 0 1 0. If I don't consider it positive or negative, it's a negative number actually. I can subtract it by 1 1 1 1 from, so it becomes 1 0 1 0, which is nothing but inverse of this. But we don't do this. We only do it for sign numbers. So what is 2's complement? 2's complement is 1's complement plus 1, we have to add 1. This is similar to, this is 9's complement. If I have 10's complement, what will I do? Instead of 99, I will subtract it from 100. This will be 3, 7. This is 72 plus 1. This is called 10's complement. 10's complement. So now I have 9's complement, I have 10's complement. Here I can have 1's complement and 2's complement. 1's complement is already did. 2's complement is is 1's complement plus 1. So let us again take a 4-bit number. We will consider as a positive number 0 0 1 0. This 1's complement will be, make it negative, this becomes 1 0 1 1. This is 1's complement. Add 1. This becomes 0 1 0 0. No. Add 1. Okay. 1 plus 1 0. So this 1 goes here, this 1 and 1 come here. So if this was 1101 as 13, this becomes 14. So it's always 1's complement plus 1. But as I said, you have to preserve the sign, otherwise there is no use for doing this 1's complement, 2's complement, because for subtraction we will use this. That is what we want to do. So whatever your number is given, first you should determine how many bits you want to do. Don't have different number of bits. You always have the same number of bits. So suppose I have a 4-bit number, even if I have a 1, don't say it as 1. You make it 0, 0, 0, 1. So 4-bit is limited. So I will give you an example. This should be one of the problems in my first tutorial sheet, first assignment sheet. I will give you the problem now. I have an 8-bit number. So I say it is 8-bit number. Whether it requires 8-bit to represent or not, I will always fill up the rest of the things with zeros. Now, so the number, when you say 8-bit representation, then suppose you have number 25. In sign magnitude form, it is 0, sign is positive, then 25 is how much? 16 plus 8 plus 1. So this is 1 followed by 0, 0 followed by 1, 1 and followed by 0, 0. Because the 7 bits I can represent up to 127 positive or minus 128 actually. That is the advantage of 2's complement. 2's complement uses the full range. It can go from minus 128 to plus 127. Whereas in 1's complement with 8 bits, I can go only from minus 127 to plus 127 because 0 occurs twice. 1111 as well as 0000 are both zeros. In 2's complement, we have an extra number which will be used to represent 256, that is minus 128 to plus 127. Now, why am I writing all of this? 25 is this is enough. This is 25. When somebody asks you to convert 25 into binary, you will start dividing by 2, 25 by 2, 12, 2, 6, 2, 3, this is 0, 2, 1, 1. You start writing as 11001. This is what we will write. Don't do that. We are going to use 1's complement or 2's complement or use it for subtraction or addition. Always ask how many bits. Do you want 8 bits? 7 bits? So 8 bit determines, if you take 1 bit for sign, 128 plus 128 to minus 127 plus 128 to minus 127. I mean minus 128 to plus 127. In 1's complement, minus 127 to plus 127. It is 6 bits number, 1 bit goes for sign. So rest of this is 5 bits, 32 to minus 32 plus 31, or if it is 1's complement, it is minus 31 to plus 31, like that. Now this is the question now. Now if I am going to give you this number 25, you first, this is defined. What is the number of bits I want to represent this as? Now I have given that this is a sign magnitude representation. Since the number is positive, I put 0, and 25 converts simply to binary, add sufficient number of zeros to make it 7 bits. That's all I am saying. Then, if you want 1's complement of this, easy, because I retain this. This becomes, since it is a positive number, I complement everything. 1's complement is 25, 1 becomes 0, invert every bit, 1. I don't invert the sign bit because it is a positive number. I invert all other bits. 1 is 0, 1, 1, 0, 0, 1, 1. If you miss these two ones, you do addition, you will run into problems, error. Again, this is 1 only because it is a positive number. 2's complement, I can add 1 to this, will be 1, 1, 1, 0, 0, 1, 1. Again it is 0, I am sorry, this is 0, positive number. This is also 0. So 1 is wrong, it should be 0. Here also it is 0, 0, 1, 1, 0, 0, 1, 1, 1. Let us take a negative number and do this. Minus 42. Is how much? Binary. Divide 42 to 21, divide by 2, divide by 2, divide by 2, divide by 2. This will be 1, 0, 1, 1, 0, 1, 0, 1, 0. 1, 0, 1, 1, 0, 1, 0, 1, 0. Sign magnitude. One, 0, 1, 0, 1, 0. Now how many bits are there? Only 6. I want 7 bits and the sign bit. So I need to add a 0. And the sign bit which is 0, negative, which is 1. Sign bit is negative, 1, and this has to be 7 bits, 1, 2, 3, 4, 5, 6, 7. The extra 0 is added to make it 7 bits. That is very, very important. 1's complement, invert each bit, 1, 0, 1, 0, 1, 0, 1. This will also become 1 because it is a negative number. So it is 1, 1, 0, 101 01 110 101 01 2's complement. Now we have to add 1 to this. 1 plus 1 is 0. This 1 goes here. 1 0 1 0 1. Again it is sign bit is 1 because all the numbers are negative now. So this becomes 110 101 10. So what I am trying to drive home is when somebody asks you to convert a number into 1's complement, 2's complement or sign magnitude, don't jump at it. First question you ask is how many bits. You want number to be represented how many bits. Sometimes they will give you too few bits, then you say it's overflow, it's not possible to convert it. Suppose I want 4 bits representation in sign magnitude, I can only go from -7 to +7. And the person gives you number 12, convert it into sign magnitude using 4 bits. You say it's not possible. That's all I am saying. Now we will see how this helps in subtraction. If you have any questions, you can ask me. Okay. Subtraction of negative number is addition of complement. Easily done in 2's complement. Can also be done in 1's complement. Very rarely it is done in 1's complement. So I will start with 2's complement. A subtraction in 2's complement. So let us say I have 4-bit representation because this is important. All the numbers I am going to give you are 4 bits representation and make it easy. Concept is explained, so I will make it easy. Now, I want to add subtract +5 -6 from +5. Is it possible or not? Yes, it is possible because result is -1. Now, what is +5? All in 2's complement. 2's complement subtraction. So +5 in 2's complement. There is nothing, it is only a positive number. So it is 0 1 0 1 5. We don't do any conversion. -6. 6 in 2's complement will be 6 is generally written as 0 1 1 0. 2's complement of this should be invert every bit, add 1. This is 2's complement of 6. Add. Subtraction is addition of 2's complement. So answer will be 1 1 1. What is this? +5 -6. 1's complement it is. 2's complement, five plus 6. I think we should do it the other way then. 5 plus 6. 5 is 1 0 1 0 1. 6 is 1 1 0. 1 0 0 1. Add 1 becomes 0 1 0 1. This is sign bit. Put these two bits together and add. Minus 6 becomes plus 6. 1 1 1 1. Okay, I know what. This one represents this negative number. So I cannot take the result as it is. I have to invert the number to get the original number. This is 2's complement number. Because I have done a 2's complement subtraction, so I take the 2's complement of this number, which is 0 0 0 0, add 1, and this is the right answer. So this tells you whether you take the number as it comes or whether you have to invert it to 2's complement. Now because it is negative, because the answer has to be negative, since you know the answer has to be negative, so this became 1, that means you are right track, but the magnitude is not right. So what do? You again convert it back to 2's complement. So the result is, this is 2's complement of this is 0 0 0 0, is 1's complement, plus 1, it is 0 0 0 1, which is negative 1. So you have to say it is negative 1. Answer. Just for a minute I got confused. Supposing it is overflowing, I will give you an example with overflow. Minus 5 minus 6. How do you know it is not correct? Using 2's complement. 2's complement, again 4 bits. Let me have some water, please. I am ready for questions. Okay, no questions? I don't like dull classes. I want interactive classes. Yes, you have a question there. Please ask.
Sir, I was asking that.
Excuse me?
So,
I can't listen to you properly.
Hello, sir.
Yes. Hello.
Sir, now can you hear me?
Pardon?
Hello.
Yes. Hello.
Sir, now can you hear me?
I can hear you, but you are not asking anything.
Sir, I was asking that while we are doing 1's complement, we are not doing the complement of the sign bit. Like in case of 42.
Why is sign bit not inverted for 1's complement? Is that the question?
Yes, sir. Yes, sir. Yes, sir.
You see, we know the sign. The number is sign. We know the sign of the number. And we have decided 0 as positive and 1 as negative. So the magnitude bits only you invert. If you invert the sign bit, suppose I have minus 3 plus 3 and I want minus 3, I will give you an example here. Plus 3 is, let us have 4 bits again, 0, 0, 1, 1. Minus 3 would be, okay, not minus 3. Minus 3 I will invert it. If it is minus 3, I will invert it, but I will say 1's complement alone. So it is 0, 0, 1. So if I invert it back, I should get 3. But if I put this inversion 1, yeah, this becomes 0, but this is only not, it is only done for minus. It is only done. So usually the complement is done only for negative. Not if you have to add two numbers positive, you don't need to know 1's complement. But then, first of all, I will explain why you want to add or subtract using complement numbers. In design of arithmetic logic units, in calculators, in computers, they cannot have too much hardware. Your arithmetic logic unit can deal with addition. If you want to build a subtractor, is again another job. So they want to have one unit which adds and the same unit to be used for subtraction. That is why they have thought of this 2's complement or 1's complement number subtraction will be same as addition. So if you have to add two numbers which are total magnitude is less than your range, then you simply add. Number being 0, 0, you add them. So suppose you want to add plus 2 and plus 3. Add 5. There is no need for taking complements. The complement comes into picture when you want to subtract, and that becomes negative. Subtraction by itself is a negative sign. So automatically a negative sign will be inserted there. That's all I am saying. You don't unnecessarily invert the sign bit of the number unless it is required as a negative number. A negative number we always put a 1 for sign bit. That is the question of not doing it. Do you understand?
Yes, sir.
Okay.
Yes, sir.
Yes? Okay, let me continue with this. Are you happy?
Yes,
Not
sir.
so happy. Not quite happy.
Yes, sir. I am happy, sir.
Okay. If you are happy.
I got the answer of my question.
Okay.
Thank you, sir.
You are most welcome. I am not drinking tea, it's only hot water. Otherwise I will give you. See, I want to share tea with you, but how do you do that?
Sir, over date we can't do that.
Huh?
Sir, for the tea I will have to personally meet you.
Yeah, please come. We'll have a tea in our canteen. So minus 5, minus 6. Both are negative numbers. What is 5? 5 is 0, 1, 0, 1. I'm sticking to 4 bits to make it easier to understand. Minus 5. Now you put minus 1. Huh? And then it is 0, 1, 0. Add 1. Hey, don't talk. There's a conversation going on parallelly. 1, 1, 1. Your comment, please mute. These people are started talking. 0, 1, 1. This is minus 5. I have to put this negative sign here. Minus 5 is 0, 1, 0, 1 is inverted. 0, 1, 0. Add 1, 1, 1, 0.
0.
And this 1 will be there, negative sign. Minus 6. First I will test what the 6 is. 6 is 0, 1, 1, 0. Invert it. Wait for 1's complement. This is 1's complement, is it? I don't want to put a 1 is a minus here. I'll put the minus here. So here also I'll put 1 as a minus sign. And this is 1, 0, 0. Add 1, 0, 1, 0. So this is now 5, minus 5. This is now minus 6. I want to add them, minus or plus or minus is same in arithmetic here. So it is going to be 1, 0, 1, 1, 1, 0, 1, 1, 0. Add 1, 0, 1, 0, 1. Now, we know it is wrong because normally we discard the overflow bit. We don't need it. If the arithmetic is proper, answer is positive or negative, it doesn't matter. The answer is, the sign bit is properly coming, this last bit has no meaning. Now also I can discard it, but then the answer comes as positive, which is wrong. Minus 5 and minus 6 has to give a negative number. You don't know the answer, but you know that both are negative. Adding negative number to another negative number has to give you a negative number. Since the sign is positive, that means this is wrong. Why is it wrong? Because the answer is 11, minus 11, and we have 4 bits, out of which 1 bit is sign bit. So I can only go from plus 7 to minus 8. It is 2's complement, 8 bits, 3 bits, minus 8 to plus 7. It falls outside the range. This is called a overflow error. So it's wrong. You cannot do this. So when the sign bit is different from what you are expecting, what is not expecting, what should be, then you know it is a wrong answer. And generally it occurs when there is an overflow. Try to put into a register a number larger than it can hold. Same thing will happen when you count in a microprocessor. A 8-bit microprocessor you are all familiar with. It goes from 00 to FF. That is from 0 to 255. You try to add some number to this, go outside the range, and it will show fold back. And then you know it's wrong. There is a mechanism to detect it. Similarly, here also we can build in a mechanism to detect it. But right now I am only talking to you the principles. So we will not talk about the hardware now. We will come to the hardware later. So this is an error. So this is what I want to tell you about. This is same thing with nines complement, tens complement. Suppose your number is 8 bit, that is base of 8, octal number, then it is 8 complement, 7's complement. If it is 5, base of 5, 5's complement, 4's complement. Hey, don't show all this. Whoever this person is, the red shirt. It's not a commercial TV to show all these stupid signs. And then there was a person who was trying to be funny. Okay. I gave a lot of problems. I always send it to NPTEL. They will dispatch it to your mentors, and there are 15 problems in this set. Lot of problems do with conversion, with addition, subtraction, 1's complement, 2's complement, etc. Sign numbers. You can work out this. After some time I will send the solutions also to the mentors. This is the responsibility of the mentors to make sure that you all do it properly. We can discuss a few of this. I don't know when they are going to give this to you. We can discuss a few of this in the next class. Now I want to go to the other topic, another topic in this. It is called codes.
So I have a
Yes.
question.
Yes.
Sir, can we do a problem on subtraction using 1's complement?
Fraction. No problem. You know how to.
Subtraction.
Same procedure.
Sir, we actually did the 2's complement method, but if it comes in 1's complement and if we have an overflow error, what do we do in that case?
You see, the fractional number you convert it into integer and fractional part in ones in binary, right? That is the
Yes.
first step. Then you convert it as one's complement in a regular way. Where is the question of error there?
No, sir. If we add both, like we have got something which is 5 and minus 5, something like that.
Okay, tell me. Whoever was talking to me, tell me again.
Uh, Sir, if like we have numbers 6 and minus 5,
6
sir,
and
and
minus 5.
in
6 and minus 5.
minus 5, sir, yeah.
It's not a fraction.
Sir, in my no. Sir, my question is, if we are taking minus 5 and we are calculating, wherever we see a negative number, we take the complement of it.
Yeah.
Instead of 2's complement, if I take 1's complement, will there be a difference?
Yes, definitely, because 1's complement, 2's complement are not the same. 2's complement is
Yeah,
1
so-
plus 1's complement. So that 1 has to be added somewhere. Is it not? I will tell you how to do that. It's called end around carry. That carry which is discarded in 2's complement, we have to bring it back and add it. That's all. I will show it to you. Now why I did not do it is, generally we use only 2's complement. All computers, calculators, microprocessors, they use 2's complements, not 1's complement. 1's complement is used long ago, not anymore. We are all modern people. I can't teach you old stuff. Okay. 6 and minus 5. 6 is 4 bits again. Sign bit 0, 0, 1, 1, 0. 5 is 0, 1, 0, 1. 1's complement is 0, 1, 0. This is a negative number, I put a 1 here. Becomes 1, 0. Oh, what is this? 0, 1, 1, 0. This is 0, this is 1, 0, 1, 0. Zero, 1, 0, 1, 0. Add 0. This is one complement addition. 0, 0. I'm adding this. 1 plus 1 is 0. And this is that overflow is here 1. 1 plus 1 is 0. So 1 and 1 0. And this 1.
1, 4.
This is called end around carry. That 1 we did not add will now be added into this. This is called EAC, end around carry. So you add this, it becomes, and this is what you wanted. 6 minus 5 is 1. Okay? It's not magic.
Yes.
That 1 has to be added somewhere. Okay, good that you are all happy. But who is the guy who was trying to do this? Huh? He came from your room. Okay. Warn that guy. Next time if he does it, the class will be suspended. Right. We will go to codes. What is a code? All of us know code. You code words with your friends. You want to tell something to a friend without others knowing what you are talking, you give in code language. Only you and your friend understand that. Similarly, password is one form of codes. Of course, we don't make it. You tell the computer what password is and it makes a code. Code is required for many things. One is to compress the number of bits that you want. So 0 to 127 is 128 different numbers. I can compress it in 7 bits. That is a code word. So each code, one of 127, one of 128 numbers. But you know exactly what code is what. It's not a secret code. Anybody knows that code. Okay? But it is to compress the number of bits. Suppose you want to switch on and switch off 127 times to one, let us say 63 you want to send, you have to send 63 times to switch on and off and on and off. It is too much work. You 63 and convert it into code word and send it. That is to compress the data. Sometimes code is done to be efficient in terms of some operation. The last thing we will talk about is secrecy. We will not talk much about it. For example, we have gray code. What is a gray code? Binary code for 0 to 9 I will write. That is normally we use binary code. 0, 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0. This is 0 to 7. I will write from 0 to 16. Now with 1 you have to repeat the whole thing. This is 0 to 7, 8 to 15. 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, 1. This is 0, 8 to 15. There is no problem. Everybody understands this. But where do we use gray code? Gray code for this would be, we will call this B0, binary bit 0, B1, B2, B3. B0, B1, B2, B3 are binary bits corresponding to a code which is normally we use. Now in gray code we will call it G0, G1, G2. Now the first column we will keep it as it is. The second column 0, 0, 1, 1, instead of 0, 0, 1, 1 repeating, we will invert it 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0, 0. We will do that. I will write it in another color maybe. This is, I can put these lines only, then it will go clearly. Oh my God. My straight lines have become nowadays curves. I used to draw very straight lines. Okay, now 0, 1, copy this. One is missing somewhere. 1, 0, 1, 0, 1, 0, 1, 0, 1, then 0, 1, 0, 1, 0, 1. I think this is 0, this is 1. Let me do it properly. You should never go to the end of the board. Like you can never go to the end of the world. Okay. Then this row, this column I will make it 0, 0, 1, 1 and again repeat 1, 1, 0, 0. 0, 0, 1, 1. Instead of making 0, 0, 1, 1 again, I will make 1, 1, 0, 0. Again 0, 0, 1, 1 and 1, 1, 0, 0. Third row, third column, 4 zeros, 4 ones, again 4 ones, 4 zeros. 4 zeros, 4 ones, 4 ones, 4 zeros. If you take any textbook, it will give you very neatly. Or go to computer and Google record. That is all. Then the last row, 8 zeros, 8 ones, and 8 ones, 8 zeros, but we have only 16, so we can copy this. What is the advantage of this? Why do you have to do this? Now between any two numbers in binary to gray code, there is only one bit change. Here all zeros, here only one. Here this one becomes 0. There cannot be 2 bit change. 0, 0, 1, 1, 1, 1, 0, 0. Something is wrong with this. 0, 0, 0, 0, 0, 1, 0, 1. Okay, I know what it is. I should have also changed this. 1, 1, 0. 0, 1, 1, 0. 0, 1, 1, 0. 0, 1, 1, 0. 1, 1, 0. 0, 1, 1, 0. Now look at this. Now this 0 becomes 1 when no other bit changes. Here also no problem. Here this bit, this 1 becomes 0, this 0 becomes, there are 2 changes. Whereas here this 1 remains and this 0 changes to 1. There is 1 bit change. Again next, 0 to become 1, this is okay. Here also 1 remains 0, this becomes all right. So between this and this, these 2 ones have to become 0, this 0 has to become 1. That means there will be 3 changes. Whereas if you look at this 0 remains 0, this 1 remains 0, this 0 becomes 1. There is only 1 bit change in every code. Every binary code, there is only 1 bit change in gray code. Whereas in binary, for example, if you take 7, 7 to 8, 1 becomes 0, 1 becomes 0, 1 becomes 0, 0 becomes 1. Whereas here, 7 to 8, this 0 remains, this 0 remains, this 1 remains, this 0 becomes 1. There is only one bit change from one number to the adjacent number in gray code corresponding to binary code. What is the advantage? Why do we have to do this? That is the question. The reason is, when you build a hardware, when you have to change from 7 to 8, there are going to be 3 changes. One, there will be 3 switches. In real digital system, it's not switch. This is some transistor or a flip-flop or some other device which will make change from 1 level, 0 level to 5 level. This change cannot occur all at the same time. However matched these transistors are, however matched these flip-flops are, there is always a minor difference in time between one change and the next, same 3 bits to change. Here example, the extreme example is, here 3 ones have to become zeros, this 0 has to become 1, whereas here everything remains same except this one. So if you make only 1 bit change, it may take a little time, doesn't matter. But in between we will not go through undesired changes. We will not go through undesired states, undesirable states. That is going to be very useful later on. So gray code, these numbers are called adjacent numbers. Between one number and the adjacent number, binary may have changes of 1 bit, 2 bits, 3 bits, 4 bits in a 4-bit number. Whereas in gray code, whether it is 1-bit number, 2-bit number, 3-bit number, 4-bit number, 5-bit number, 6-bit number, there is only one change in bit position. But in 2 adjacent states, there is only one change in bit position. This is very useful property. That is why people go for gray code. Very useful, especially when you go for very fast switching operations. Today's computers work in nano, gigahertz, which means switching is sub-nano. Nano itself very small, 10 to the minus 9. 10 to the minus 9, 10 to the minus 12. People are talking about 10 power minus 15, femto and all those things. And they have such speeds, on each of these will have a very small delay time. But even a minor change in delay time can affect the speed of your computer. So that is why they want to make this. Gray code is a very useful code, especially when you come to fast devices, fast switching operations when you need to do that. That is why we need for gray code. So these are all standard codes people use all the time. Then there is one more code called the XS3 code. This is not a very special code. As it says, name says, is XS3. The number plus 3. A binary code you give the XS3 code will be, this is the binary. Sometimes they write XS3 as this. Add 3. So we will write from 0 to 10, 0 to 9. This is 9. This will be 9 plus 3 is 12. Again, what is the advantage? The advantage is very simple. Actually, now we don't need that. Olden days they used it. That is, when you have a number, it's called self-complementing code. Access3 is called a self-complementing code. What does it mean? If you take 9's complement of number and express it in access3 code, a number in this 9's complement is same as 1's complement. For example, I will tell you. You take a number 395, I will write here. Number 395, if you write each digit as a binary number, 0011, 1001, 0101. And if you take 9's complement of 395, what is 9's complement? Subtract 395 from 9999. Becomes 406. 604. If you take 604, it becomes 100. 0011. This is 3. 6. 0110. 0000. 0100. So this this is 3, this is 6, this is 6, 6, 6, 12. So you have to add, in access3 if you express this, if you express in access3, it becomes, add 3, becomes 3 plus 3 is 6. This becomes 12. This becomes 5 plus 3, 8. When you express this in access3, this 6 plus 3, 9. This is 0 plus 3. This is 5 plus 3, 8, This is 4 plus 3, 7. So this access3 of 395 expressed in binary is inverse of access3 of 604 expressed in binary. That means if you want to find a access3, you take the 9's complement and then gets its inverse. I don't know what is the big advantage. Earlier days in the computer, they used this as a sort of an example, to simplify the addition. Today this is nothing. Adding 3 to a circuit is not at all a big problem. So it's not a big issue, but you know what it is. If you know what the access3 is, that's enough. Add 3 to the given number, each bit. I mean, not each bit, each digit of binary, each digit of decimal, you convert to binary, add 3 to it. Then it becomes access3 code. And inverse it, you get the access3 of the number which is the 9's complement of the original number. What is the big advantage of this? not much today. Earlier on, computation seems to be a big advantage. When the computation was limited and the facility of computing. And there are other codes. One important code all of you know is ASCII code. You know what ASCII code is? How many of you know?
American Standard Code.
Excuse me? Say it again.
American Standard Code for Information Interchange.
That is right. But do you know what it is? How do you express an ASCII code? A given
I
letter,
just know the standard.
you know the expansion, right? That is good.
No, I know the standard, like for alphabets for different
Yeah. How many bits
special
are there?
characters.
How many bits are there in ASCII code? How many, who knows? How many bits? How many bits in ASCII code? Yes, you know. Tell me.
8 bits.
Not necessarily.
8 bits.
7 bits is enough. 7 bits is giving you 128. No. How many bits? How many alphabets are there? English alphabet, how many bits? How many alphabets?
26.
26. Uppercase. 26 lowercase.
Okay.
How many?
Special
52.
2.
Special characters, numbers, numerals, all that put together 127 is enough. So the extra character is used as parity. I will tell you what a parity is. So since all of you know ASCII code, I will not spend much time. It is an American standard code for information interchange. Everything has been American, you know. I don't know why. Why not you have Bharat standard code for information interchange? Huh? And then you are going to become self-sufficient in all this. American standard code for information interchange. Again, all these things you can get in any textbook or go to the Google. So there are 127 characters or 128, and each character A will be one code, A will be one code. For example, A is, I wrote somewhere here,
64, sir.
yeah, you seem to know everything. 60, A is 100, 0001, 7 bits. Small a is 110, 0001. There is only one character different, 1 bit difference. Then numerals, then special symbols, then all these things you find in the keyboard. Now the 8th bit is used as a parity bit. What is a parity bit? You see, when in information, there are 2 problems. When the information is transmitted over channel, it's bound to have some errors. It can pick up some errors. A 0 can become 1, a 1 can become 0. So there are 2 things called odd parity and even parity. In odd parity, if the symbols, if the bits you are transmitting, if the word is called a word, number of bits together called the word. They will count the number of ones in the word. If it is odd, they will put a 1 as a parity bit. If it is even, they will put a 0. In even parity, if the number of 1 is even, they will put a 1. If it is odd, they will put a 0. On the other side, they will receive this and they will get the parity bit and count the number of bits. If it does not match, then there is an error of one of the bits. It is a 1 bit error. You can only detect it, you cannot correct it. Error detection code. Parity bit is an error detection. 1 bit error detection. All you can do is to ask them to send it again. You got an error, there is a corruption, not the type of corruption we see in India. This is the corruption in the bit. Okay? The corruption of the bit. So you ask them to send it again. Then again you would come to can't do anything. You have to you have to wait. There are also lots of codes we are not going to discuss now called error correction codes. So you need, they will send a block of words and then they will send the column addition and row addition, and with both matches is okay, otherwise they will say this bit is an error and all that type of thing. There is no, it's not in the scope of this lecture series to talk about all these codes, but you should know what a code is. How these bits, zeros and ones are used to represent codes. It can be gray code, it can be XS3 code, it can be ASCII code, it can be parity bit, whatever it is. So I'm going to stop here today. Are there any questions? Please, Professor Kannan, please throw the...
Yes, sir. Yes, sir. Yes, I'll unmute them.
Yeah.
Yes, sir. I have unmuted everyone. You can go ahead, sir.
No, don't ask me. I don't have anything. I have finished the lecture. Any questions? You understood everything?
Yes,
So,
sir.
next lecture I am going to ask first 10 minutes questions from the tutorial sheet. You'll see how you are responding. First 15 minutes. What is called a pop quiz. We call them pop quiz.
Sir.
It's a surprise quiz. Yeah, we will tell you the date and time, but what questions come we don't know. That is called surprise quiz. It is a tutorial sheet which I already sent it, and I don't think it will go to the thing. Yes, Kannan.
Sir, most of them, about 50% of them, I think they have some classes and they are coming late. So we'll have a nice session at 5 p.m. Between 5 and 5:30 will be a nice session for you, sir, because everyone will be present and you can have a good tutorial session or a participative lecture.
Okay, no problem. Anytime, as long as they come out and speak. What I want is not talk to dead video screens without any animation. I want people
Yes, sir.
to talk and respond and show your hand so I can stop and ask them what do you want and things like that. I always like the interactive lectures. Otherwise you feel bored, 1.5 hours talking without any questions and interruption, it is boring, you say. You try to stand here and do it. Yes, you have a question there. Tell me.
Sir, please
Hello,
explain the parity bit again.
See, I am now running out of my throat. I will do it first thing tomorrow. Okay?
Okay, sir.
Yes,
Okay,
sir.
sir.
Because you know that I was choking towards the end. My cough was suppressed so far. It's,
ஓவர்ஃப்ளோ எரர் வந்ததுக்கு அப்புறம் நெக்ஸ்ட் ஸ்டெப் நான் சொல்லவே இல்லை அவரு
Huh?
ஓவர்ஃப்ளோ எரர் வந்து
Sir,
Overflow
please,
error. Tamil
someone
understand?
wants to do
No, sir.
something about overflow, sir.
சார்
Ah.
when overflow errors occur
Ah.
what we want to do next step
You don't use it. Data is wrong. The addition is wrong. That means you are adding numbers whose result is more than your number of bits can be used for representation. What is the exact question, madam?
sir when overflow error occur the number is wrong
Number is
is
not
it mean
wrong.
sir
Tell You are speaking in Tamil, so you can talk to me in Tamil. Yeah.
okay sir
Ah.
சார் ஓவர்ஃப்ளோ எரர் வந்து இப்போ 11 -5 and -6 சொன்னீங்கல்ல சார்
Ah.
அதுல வந்து நம்ம ஆட் பண்ணதுக்கு அப்புறம் we got one ஓவர்ஃப்ளோ எரர் வந்துச்சுல சார்
Ah.
அப்ப அந்த நம்பர் என்ன வந்து ராங்னு
No,
சொல்றீங்களா சார்?
Raj, the reason is I'm expecting minus 6 to be a negative number,
ஓகே சார்.
but I got a positive number as the result.
ஓகே சார்.
That is error. So that is why is that error coming? Because 11 cannot be held in 3 bits. Out of 4 bits, 1 goes for sign bit. Only 3 bits magnitude, that means 0 to 7, plus or minus. So how can you have 11, whether positive or negative, using 3 bits? That is why the error came. What else?
ஓகே சார்.
What else do you want to know about overflow error? Tell me, I can tell you.
இல்ல புரிஞ்சிச்சு சார்.
Okay, good. Which college are you? Tamil speaking girl. Which college?
ஆல்பா காலேஜ் ஆஃப் இன்ஜினியரிங்.
Yeah, why don't you speak in English?
I'll speak sir. You only asked me to speak in
No,
Tamil.
because you are talking in Tamil to start with.
Yeah, that's why I was talking Tamil sir.
Yeah, I can also understand English, Tamil, a little bit of Hindi, Sanskrit, German. Okay. Right. Thank you very much. See you next time.